Hello everyone. In this video we're going to be solving a cubic equation. We have x cubed plus 4x squared equals 5, and we're going to be looking for all solutions, real and complex. Alright, so first of all I want you to notice one thing here, which is very important, and I mentioned that before. When it comes to polynomials, you know, it's important to check a couple certain things, like, for example, could x equals 1 be a solution, x equals -1, stuff like that. So if you replace x with 1 here, you'll notice that 1 plus 4 is equal to 5, obviously. So x equals 1 is a solution to this cubic equation. Okay, now I'm going to put everything on the same side and then factor this equation, knowing that x equals 1 is a solution. So let's go ahead and take out negative x squared. That's going to leave us with 5x squared minus 5. Now let me explain why I'm separating the negative x squared. I want to get x minus 1 as a factor, but I have to start with x cubed. So if you think about multiplying the x minus 1 with x squared, then that's going to give you x cubed minus x squared, which is divisible by x minus 1. That's why I'm trying to split it up. You could also do long division, synthetic division, all sorts of division to do this. Okay, now let's go ahead and factor this by grouping. This is going to give me x squared times x minus 1 plus 5 times x squared minus 1. Now we know that x equals 1 is a solution. That kind of helps us factor this. Also, we know that x squared minus 1 is factorable by difference of two squares, right? Like this. Great. Now I have x minus 1 as a common factor. That shouldn't be a surprise. X minus 1 is a common factor because x equals 1 is a solution. So let's go ahead and take out x minus 1 and try to find the other solutions. And from here we're going to be getting the following. The first term is going to be x. Okay, let's see. The first term is going to be x squared, and then we're going to follow up with, we're going to have to distribute the 5 here, plus 5x plus 5. All right, great. Now we're going to set this equal to 0, and from here, as you know before, x equals 1 is a possible solution, right? I mean, not a possible solution, it is a solution. The other solution is going to be coming from this quadratic. Let's go ahead and take a look at that. So if you solve that quadratic by using the formula, because it doesn't look factorable, x is going to be negative b plus minus the square root of b squared minus 4ac. A is 1, so 4 times 5 is going to be 20, divided by 2a. And from here, x value is going to be given as negative 5 plus minus square root of 5 divided by 2. Great. So as you can see clearly here, we have 3 real solutions. Sometimes with cubic equations, we only get one real solution and the other solutions become complex. And you can tell by the graph. At the end of this, I'm also going to show you a graph of this function. So those are my solutions, and we are basically done. But let's go ahead and take a look at this from an analytical perspective. So I'm going to consider 2 functions here. First function is going to be y equals x cubed plus 4x squared. And the other function is going to be y equals 5. So I'm basically looking for the intersection point for these 2 graphs. Now, why did I separate them like this? Because initially they were separated, and also the first function, the cubic, in this format is actually easier to analyze because it's factorable. So let's go ahead and factor it. If you take out x squared, you're going to get x plus 4. And now from here, you can safely say that by setting the y equal to 0, you're going to get 2 x-intercepts. It's important to know the x-intercepts because those are basically the roots of this, but not the original of our equation, because our equation is different. Now, we know that this cubic function here, y equals x cubed plus 4x squared, has 2 x-intercepts, 0 and negative 4. But at 0, we have a double root, which means that it's not just an x-intercept, but the graph is supposed to be tangent at 0. And we're going to look at the graph a little later. But first of all, let's go ahead and see what the derivative looks like. Let's go ahead and differentiate the first function. That gives us 3x squared plus 8x. Interesting, we still have 8x as a factor, which means that I can find the critical points from here. Set the derivative equal to 0, and I'm going to make a table. From here, I get x equals 0 and x equals -8/3. Those are my critical points, so I'm going to make a table like before. We've done this. This is going to be x, this is going to be y prime, and this is going to be the y value. So we know that y is 0 at -4 and 0. So -4 and 0. Y is going to be 0 like this. And then at -8/3, something like this. -8/3 is obviously closer to 0, right? And 0, our derivative is going to be positive. So let's go ahead and now take a look at how the sign changes here. Okay. All right, let me pick something lighter. So, is our derivative positive or negative in any given interval? How do we find out? Well, this is the derivative, and if you think about like replacing x with 1, for example, right? For x equals 1, y prime at 1 is going to be 11, which means it's positive. So of course, this is not like a technical method, it's just trial and error, but that works because at every interval, it's going to change. Our derivative is going to be positive when x approaches infinity, when x is positive, in other words. In this interval on -8/3 to 0, it's going to be negative, and it's going to be positive again. Of course, it's not going to change when the y values change. Here, our y values are going to look like this. When the derivative is positive, our function is going to be increasing, but as it's increasing, notice that it's going to have an x-intercept at -4. So it's kind of going to go like this. Obviously, that's not a straight line. It's supposed to be curved, but you'll see the graph in more detail a little bit later. And then it is going to decrease, and then it's going to increase. So we have a maximum here, and we have a minimum at 0. And notice that at 0, the y value is also 0. So in other words, we have a tangent at 0, 0. And this brings us not to the end of this video, but to the graph. Here we go. The graph of y equals x cubed plus 4x squared and y equals 5. You can see here the 3 intersection points. These are the radical ones, and this is the value where x equals 1, and of course y is equal to 5. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.